Hey guys, welcome to this session. Our main topic is the measurement of thermal energy. Uh, they will start talking about the specific heat capacity. So let's dive into it. Now let's see the concept of specific heat capacity. Uh, Specific heat capacity, this is the quantity of heat that is required to raise the temperature of a unit mass of a substance by 1 degree Celsius. So the amount of or the quantity of heat that is needed to raise the temperature for a unit mass may be 1 kg of a substance by 1 degree Celsius. Now the quantity of this heat supplied to or taken away from a body depends on various factors. The first one is the mass of a body. The second one is the temperature difference that can be obtained by the final subtract by the initial temperature, and the estimate the thermal properties of the body. Here we're talking about uh, the properties of a body to contract with heat. Moving on, let's see the behavior of particles of matter by applying the kinetic theory. Now, let's have to see the concept of kinetic theory. Uh, the kinetic theory of matter says that a matter consists of many very small particles which are constantly moving and in a continuous state of motion. Now, the degree to which these particles move is determined by the amount of energy they have and their relationship to other particles. Now, the particles might be these atoms, molecules, or ions. So, this kinetic theory, also known as the particle theory, it just explains the correlation between these particles and how they move in relation to the amount of energy they have, and relating to all these particles, the atoms, molecules, or ions. Now, the particles theory, this kinetic theory helps to explain the properties and the behavior of materials by applying the model, which enables us to visualize what is happening on a very small scale inside those materials. Basically, those particles move inside a material. Now, let's see the change of state in a heating curve. Now, let's see the definition of change of state. Change of state, this is the transformation of the condition of matter from one state to another caused by the change in temperature. Now, the following are just few of the changes of states in the heating curve, starting the first one that is melting. Melting, this is the process of change of state of matter from solid into liquid. For example, maybe ice into water. While the melting point, this is the temperature at which this solid substance tends to change into liquid. Freezing, this is the process of change of the state of matter from liquid to solid. Take an example, maybe water into ice. And the freezing point is the temperature at which this liquid change into solid. Take an example, maybe water changes into ice at 0 degrees Celsius. Evaporation, this is the process of changing liquid substance into vapor or gas. While sublimation, this is the change of state of matter from solid to gas and vice versa without passing through the liquid phase. Take an example, this is ammonium chloride and iodine tends to sublime. Sublimation point, simply this the temperature, the temperature at which a solid tends to change into gas and vice versa without passing through the liquid state. So sublimation point is specify the amount of temperature. Dilation, this is the change of state of gaseous state of matter into this liquid state. Take an example, maybe steam into water. Deposition is the change of state matter from gas into solid. Take an example, the ammonium chloride vapor, the iodine vapor into solid, which is ammonium chloride and iodine. So these are just changes of state in the heating curve. Now let's see the effect of impurities on the freezing point and the boiling point of a substance. We've already seen the concept of freezing and boiling, freezing this kind of change of liquid to solid. Take an example, maybe water to ice. While boiling is just change of water to gas. Now the effect of this dissolved substance on the boiling point and the melting point means that the addition of impurities will result in increased the boiling point and the melting point. Now let's start with the effect of impurities on the boiling point. When an impurity is added to a substance, its boiling point is elevated. This means that its boiling point is increased. Now, the elevation in boiling point increases with the increase in the concentration of the solid. Basically, these impurities, because when adding the solid to vapor, pressure of the solution becomes lower than the pure solvent. That is, from there you can see that the solution has to be heated more to make the vapor pressure equal to the atmospheric pressure. That is, the boiling point is elevated. Like an example, maybe boiling point of water is 100 degrees under normal atmospheric pressure. If we add maybe sugar or salt to its water, its vapor pressure becomes lower and the boiling point increases. So generally, when maybe 1 mole of any non-electrolyte is dissolved in 1 liter of water, the elevation of boiling point is 0.53 degrees. See the effect of impurities on a freezing point. Now, taking maybe when an impurity is added to its freezing point, is added to a substance, its freezing point is lowered. This means its freezing point decreases. The depression in the freezing point increases with the increasing concentration of the solid because adding of the solid, the vapor pressure of the solution becomes lower than that of the pure solvent. Now, since the freezing point is the temperature to the vapor pressure of liquid in the solid phase are equal, therefore the solution will this will occur at the lower temperature. Take an example, maybe the freezing point of water is 0 degrees under normal atmospheric pressure. Now, if we add maybe sugar or salt to this water, its vapor pressure lowers and the freezing point decreases. So generally, we can say that when 1 mole of any non-electrolyte is dissolved in 1 liter of water, the depression in the freezing point of water is 1.86 degrees centigrade. So that's all for this video. I hope it's clear. We've dived more into the various subtopics of this topic, starting the specific heat capacity. We've seen the behavior particles acting to kinetic theory. Then we've seen various changes of states in this curve, and then we've seen the effect of impurities on the freezing the boiling point. Thank you.